In the previous tutorial, we went through how we can show that the sum of the geometric series S sub n is equals to that rational expression that we have right there. And just a reminder, what we had to do was we just had to multiply this equation by r to come up with what we called equation 2. And we called this equation 1, and we just subtracted equation 1 from equation 2 to give us uh, to show us what S sub n was if we did that. Okay, but in this case, we're going to try to do it a bit different. We are going to try to use the principle of mathematical induction to try to come up with the same. Of course, it might not really appear the same at the end, but as long as we follow the rules under that we're supposed to follow when we're using the principle of mathematical induction, if all those rules are true, if they are satisfied, that means we are on the right track. Okay, but before I continue, just in case you're new to the channel, we have a lot of content that is coming up, both in mathematics as well as several tutorials that have like engineering related content, both theory and practical. In case you have not subscribed, hit the subscribe button, ring the notification bell so that each and every time that we upload new content, you'll be the first one to be notified. Okay, so that you don't miss out. So there are key three things that we have to keep in mind, or that we have that have to be satisfied as we try to use the principle of mathematical induction. The first point is we have to show that it is true for n is equals to 1. Okay, that's the first point. When that one is not satisfied, then I believe there's no point of continuing trying, because it's like there are three steps that we have to go through. So if the first one has failed, that means there will be no need of continuing, meaning it is not true. Okay, so the second one, we also have to show that it is true for n is equals to some variable. In this case, I'm going to use k. It can be anything. It can be m, it can be b, or anything that you desire to use. There's no harm. Then the final step is that we have to prove that it is true for what? For n is equals to k plus what? K plus 1. Okay, so as long as these three points are satisfied, it doesn't really matter whether it looks the same as what we have here, but of course we are going to use that as well. As long as these three are satisfied, then what we have right here, it is what? It is true, because you're going to use this one and this one together. Okay, so as showing to say is true for n is equals to 1, this is what I'm going to use. Okay, that's what I'm going to use right there. So I'm going to say, okay, I have my s. Okay, but in this case I'm not going to say s sub n. Where there's n, I'm going to replace with 1, because it's a 1 that we are using in this case. So that would be our a. Then we have our r to the power 1. I don't have to put it there, it's already there. So that would be divided by r minus 1. So we observe to say this part and this part cancels out. So what we end up remaining with is that is our s sub 1 is equals to what? Is equals to a, which is very true, because we have an a there, unless if it wasn't, we didn't really have an a there, unless maybe it was some arrangement such that maybe it is a times r plus a times r squared, such that this was representing the first term. But in this case, what is representing the first term is a, and that's what we have found. Hence it is what? It is true. So we can continue, unless if it was the other way around, unless if it was the opposite. Let's say it wasn't equal to the first term, meaning there's no use of continuing. Okay, so the next step that we have to what we have to do here, that we also have to show that it is true for n is equals to what? N is equals to k. So I'm going to use both this one and this one right here. Okay, so here this is our s sub n, this is our s sub n. Okay, so it's like this part here is equals to what? Is equals to that part, and that's what we have to that's what we have to show. But in this case, I'm going to show it in terms of k, not in terms of n. Okay, so it basically means I will just indicate to say here I'm talking about s sub k, but the rest I'm going to write it down. So I'm going to say I have my a plus ar plus, then I have this space here, then I'm going to have my ar to the power k minus 1. We say this is equals to what? A, then we have your r to the power k minus 1 divided by r minus 1. Okay, so this part is equals to that part, because we observe to say the only thing that has changed is the fact that earlier we are using n, but now we are using k, which is like there's no much of a difference, because in this case our k is going to represent the position at which we are in terms of the series. Are we on the first one, the second one, the third one, or the nth one in this case? Okay, so now we then have to prove that it is true for n is equals to k plus 1. Okay, so now we have to show that this one we're going to say our a here plus our ar plus, um, we have this space here, then I'm going to have our ar, so that would be like I'm going to I'm going to write this as I'm going to write this as k minus 1. Okay, then what you're going to have here is that we are going to add another expression. Added quite a term, or let me just say quite an expression. Yeah, I'm going to add another one. That other expression that I'm going to add, it is more like ar to the power n minus 1. But where there is n here, I'm going to replace with what? I'm going to replace with k plus 1. Okay, so replacing by k plus 1, that would be a to the power, I mean ar. Okay, ar, we are supposed to have k minus 1, but in this case this is supposed to be like plus 1 minus 1, of which that just gives us k. Okay, we have k there because we have like k plus 1 minus 1. That would be k plus 1 minus 1. That gives us a 0. Hence, we just remain with k. Okay, so this is equals to a, okay, r k plus 1 minus 1 there, okay, divide by r minus 1. I think I can leave this one here for now. Okay, so it's more like we are trying to show that this side is equals to this side. Right, I think it reminds us of what we used to do when you're talking about trig identities and stuff. So this part, our left hand side has to be equals to the right hand side. That's what we're trying to show. If it is true, if we show that they're equals to each other, then we are safe. Okay, so just a reminder, just to bring us back a bit, this part here, does it look familiar? Of course it does. This is simply what we have here. Okay, and this part is equals to what? It's equals to what we have here, but we are going to write it in terms of k. So instead of me writing what I have here, okay, I'm going to write this in terms of what? In terms of k. So that would be my a, okay, r to the power k minus, not really minus 1, but just k. So divide by r minus 1 plus a r to the power k. Okay, we have a 1 there. So I'll have to shift this a bit. We'll need it for reference purposes. Okay, so our common denominator in this case is our what? Is our r minus 1. Okay, meaning this side, what do we have? We have our a, we have our r to the power k minus 1. Then this side we're going to have going to have say plus a r to the power k open bracket r minus 1. Okay, so we can expand this. That would be a r to the power k minus a plus a r to the power k multiplied by r to the power 1 minus a r to the power k divided by r minus 1. So what we observe here is that this is negative, this is positive, and that's negative. It's able to go. So remain with this one and what we have right there. So now observe to say I have a r to the power k multiplied by multiplied by r to the power 1. These two, r k and r, they have the same, like it's the same base. We just have to add the power there. So I can write it in terms of a r to the power k plus 1, but I'm going to move it on the other side. So this will be not really, I just want it to be the positive to be on my left hand side. So that would be like my a r to the power k plus 1 minus this a that I have here, okay, minus a divided by r minus 1. So we can factor out the a. That would be our a open bracket r k plus 1 minus 1 there divided by r minus 1. of which we're able to see that what we have, our left hand side is equals to what we have on our right hand side, meaning whatever that we are doing is very much correct. And that's how you go about using the principle of mathematical induction. It's not only applicable here, it's applicable in a lot of ways. Okay, as I said earlier, it doesn't have to look the same as what you have here, but as long as it satisfies those three key points, then it means we are on the right track. And that's all in this video. Thank you very much for watching.